Okay, so now you can see my screen. We have already discussed these issues in this notebook, marked down, and I've shared some beautiful links for you to advance your knowledge in Markdown. Very important. Then we talked about the Zen of Python, which are like some principles or not really commandment principles, which makes you do some nice coding in Python program. And then we just worked few things about how Python works and what we can use Python for. Most important things are from variables and how you can manipulate variables. We talked about data types and how you can check the type of a variable. The type function can be used to do that job. If you have created a variable, you want to check what data type is being held by this object or this variable. Type, then you put into the parentheses that object which you want to check its type. It's so simple to do, and it's some English type of sort of something like that you want to say, which is spoken in some broken form. We looked at the string data type, like m is equal to this in a basic form. We have not really taken it in an extensive way. We will do something like that about it soon. Then we talked about lists. We talk about basic data structures in Python: lists, dictionary, tuple, sets. We have talked about lists. We were talking about dictionaries. Yeah. So we talked something small about dictionaries. It's just the way the dictionary is structured. That way of storing data is what Python calls a dictionary data structure. So you can have something like what we have seen here, maybe a list of persons and their age. Person 1, age. Person 2. We can do that kind of data structure on a sheet of paper or in some word processor. And you can do same in Python by coding it this way. We can do, maybe you want to store, we are keeping inventory. We are taking inventory of the products we're dealing. So we want to capture the details as follows: the type of the product and how many quantities we have in inventory. That kind of data structure is the dictionary data structure. And Python provides a way for you to keep all of these forms of data, reflecting the various ways that naturally we even keep data, either on a sheet of paper, in a word processor, or something else. So it's the same thing. We are not really reinventing anything. It's just that we are doing the same thing programmatically. That's the difference. You are programming the very things you've been doing so that you can automate and give yourself some freedom. Otherwise, you will labor till you die. That's the whole idea of programming. Okay, so let's look at some of the things. We're looking at some of the things you can do when you have a dictionary data structure. Let me try to create a more business-like one. So let's say products inventory. So we are creating that object called product inventory. And what we want to do is we want to list the product types and then the quantities that we have in inventory. And that fits the dictionary data structure. So because we want to keep the data in that way, we have to tell Python, okay, this is how we want to keep it. If you want to keep it as a list, you tell Python, I want to keep it as this data structure, because you employ a lot of calculations and even algorithms on them. And therefore, the Python needs to understand exactly how things are stored to do all of those kind of magic. That's why you need to take these issues very important. So dictionary is curly braces. So when I do this, I can press enter because I want to type it vertically to give it some structure, like the first one I demonstrated. But you can write it one line horizontal, just that it will not bring out the structure for you to even understand exactly what you are doing. That's why you can do it this way. And that's how almost everybody is doing it in the community. So if you do it this way, you also kind of, you can share your data easily with someone. You can also use someone's data because you are kind of following the same structure. So let's list our item. So I'm just going to use any kind of item. So let's say cassava. So cassava is a label, it's a string. So you have to put it in quotes. You don't need to forget about that. Otherwise, Python will speak back to you, say, hey, you've kind of broken one of the rules in the language. I guess so. And it will try to trace, not try to actually trace where the confusion, where he doesn't understand what you are speaking. So it's always very important to read your error messages. And it shouldn't frighten you. It shouldn't make you feel nervous. It shouldn't make you feel like you are not really understanding it. No, it's a communication. Even in the spoken language, you can get what they call slip of tongue or whatever. So you can also get the same thing, maybe in this case, slip of fingers. You can mistype. And therefore, the program will tell you, okay, this is where I see, I don't really get what you're trying to say. So please check. And sometimes when you go and check it, it's just because you didn't bring this quotation. If you really understand what you are doing, the errors are just like feedback for you to, oh, okay, I get you, sort of. So try and understand what you are doing. So we do colon to separate the product from the inventory value. So let's say this one, we have 100 pieces. Then we do comma, we come to the next one. Let's say this is cocoyam. And then this one, is, let's say 200, comma, plantain. Plantain is 20. Tomato, tomato is let's say 10. So they are all in maybe boxes. So 10 boxes, comma, sorry, this should be comma. And then we have, let's say, pepper. $90. So we are done. So you have
So
to,
please, I think the plantain, you did full stop instead of comma.
oh, okay. Thank you very much. Thank you. So let's say these are the items that we have in our stock. And this is the inventory taking. We are going to store it in this data structure. We are going to give it this name. In Python, this is called, anything you create, Python sees it as an object. So that's how come they call it object-oriented programming. So you can read something, you can read about it. What is object-oriented programming? Just to familiarize yourself. You don't really need to understand all the stuff there, but at least you need to know about, okay, this is there. This is basically what they are saying. So we store it and give it this object name. The object name is also referred to in texts as identifier. So when you are reading and you see identifier, variable name, object name, even if there are differences, the differences are very small. They are almost, we use them mostly interchangeably. So mostly this is the name that we will be manipulating the data from. So the naming is very important. And you have to read on the internet about the best convention to follow when you are providing an object name or an identifier for the objects you are creating. Most of them are common sense, like it should be descriptive. For example, I am keeping a data on stock of items. I can't just store it as X equals, what is the meaning of X? X can be anything, it's not descriptive. Even you yourself who did that program, after some time you can forget, let alone someone who doesn't know what you are doing. But when you do it this way, product inventory, it creates a very good context for people to understand what you are thinking for doing things the way you are doing them. So we create it by pressing Shift Enter. You can do Alt Enter. You can do Control Enter. By now you should know the difference. So it is created. If there is a problem with the way you spoke to Python, sometimes like he intelligently spotted out, instead of here, instead of comma, I think I got a slip of fingers. So I pressed full stop. And we make these mistakes every day, even in spoken language. So I corrected it. So if he had not seen it and say I ran the program, it will just throw error back at me. It doesn't mean I should just, I don't even know what to say. I should run away, I should get frightened, and therefore just get that bad attitude about the course or program. No, no, no. So it was just here. So let me intentionally redo what the mistake was and run it for you to see. Okay, so it will do this. It's only telling you that, yes, we are trying to speak. You are speaking with the program. It's like a robot. And it is built to understand a certain language. It has a dictionary. It has a collection of all the words, which are good words. So when you speak, it's just like when you are typing in Word and you type something and the word is foreign to the dictionary, which is built into Word. It will underline it. It's just speaking to you that I have not seen this word before. It's not in the content I've been provided words to track these kind of things. So that's what is speaking to you. I don't really seem to understand what you were trying to speak here, and it will tell you exactly which place of your code where he doesn't understand you. So let's see. Cell in 82. So this is cell 82. Cell, the in here is like as the input cell, because when you run, you also get an output cell, which brings the results. So input cell number 82 here, comma, line 4. So 1, 2, 3, 4, line 4. And then it tries to bring you what is at line 4, plantain, colon, 20. If you really understand the language, this is just so informative. Oh, okay. But if you are the type where you don't want to understand anything that you are doing because you want to waste your own time, then you cannot even see this because you don't understand the language and you don't want to understand the language. And the course will always be difficult for you. You can fail and fail and fail and fail and fail because you came here to learn to understand. So you have to understand before you can be passed. And that doesn't make me a bad person. Okay, so we have seen the problem and then we go and do the correction. So it should be comma and then I run it again and it's okay. Yeah, I understand. I understand you now. Okay. You wanted me to create a dictionary. Yeah, I've done it. Mostly you will want to probably, of course, let me also say this. This one, entry, each entry, in this case, each item of inventory or each product, the product name and the quantity constitute what we call key value pair. These are the elements of the dictionary, and it's a key value pair. Just like a dictionary that we use to find words. The word is the key, and the meaning, those interpretations they've given about the word is the value. And if you look at how we use dictionary, we've always been tracking meaning from the word. In this case, the key. We look for the key first, and then we trace it to the corresponding meaning of the word, in this case, the corresponding value. So dictionary also works that same way. It's not like, what do we call it? Lists, which is indexed. So each entry has an index number, and we can find the elements in the list by their index number. This one doesn't work like that. This is not indexed. So if you like, in this case, the index is the keys or are the keys. The indexes or the indices is the keys. Just like dictionary, we use the word to find the meaning of the word. We use the keys to find the values of the keys. So you can do these kind of things. They are built-in methods which work on this object for you to get those things. So let's say you want to get the value of cassava, you want to get the value of cocoa, you want to get, so there are functions which are automatically built for this data structure that you can use to extract those kind of meanings. So let's look at some of them. For example, you can do, let's say you want to get the quantity of cassava. You can do product, and of course you need to always refer to the object's name. So product, inventory. I can do this square brackets. This square brackets in this context doesn't mean less. Just like in spoken language, we can have one word which can mean multiple things based on the context. So we have the same square bracket notation, but in this context, it means something different. In the first context, like this one, it meant that we wanted to create items in a list way. In this context, it means that we want to access something from the object. So product inventory square brackets, when I do cassava, and it has to be the same way you typed the key. It is very case sensitive. So if you don't do it like that, it might throw error. So when I just do this, when I access cassava from the product inventory, it tells me the value is 100. I can also do the same thing by typing the code in a different way. This is also seen in spoken language, you can do one thing in multiple ways. So you can do this one, products, let me type, products inventory dot get. So this is some small function which works on dictionary. So it's a method, the get method. I want to get some value through the key. So product inventory dot get, and it's a function, so it will have open closing parentheses. And what we put inside the open and closing parentheses is called argument. And in this context, it is the product that we want to get its value. So if it is the same cassava, we do cassava. And it is 100. Okay, so that's how you can find some products and its corresponding value. Yeah, because of the way we have stored the data. At some point in time, you might also be interested in seeing, okay, in this data that I have stored in a dictionary form, what are all the keys? Maybe you are now coming to familiarize yourself with the data to see, okay, these are the things, or in this case, these are the products that we have. So when you want to do that, you can simply do products product inventory dot keys. So it's like that is English. So the dot keys is also a method, or it's a function. Function and methods are the same thing. We just change the name if the function is kind of automatically built onto an object. So you say it's a method, but they are all functions. So the dot keys function will extract all the keys for you. So you have to see here, we don't pass any argument because we want all the keys. So let's run it and see what we get. And let's read our error method. It says cell inputs 90 line 1. Okay, so that's just one code. Attributes error. Dict object has no attribute key. Okay, so the function's name, so this is where understanding what you are doing is so important. The function's name is actually keys. It's not key. So I mistyped, and we make these mistakes even in everyday life. So Python knows it to be dot keys, and I have typed a different thing, so it will alert you, okay, I don't seem to understand you at this part to bring you everything. And then, okay, when you look at it, and if you still don't really get the sense of what mistake it is, copy the whole error code. Copy the whole error code. So let me do that kind of experimentation. Now it is dot key, right? And let's say I'm learning, and that's how everybody began it. I'm learning, so I don't even know that the problem is that it is keys. I have to copy all of these things. I'll copy it like this. And this is my chat GPT. You have to, it has to be by your side when you are learning. And then I put it, maybe I can even give a context. I can say, okay, and sometimes you have to engage ChatGPT like you are engaging a human being, because that's how it is. It's a human being in terms of how it thinks. So I was learning to code This is how I want to type it. You can type it in a different way. Learning to code in Python. And I typed this code. I typed this code. Full stop. Okay, I'll do colon because I want to bring the code. So I'll put the code here. I insert it. Maybe I'll come another line. Tell me what is wrong with the code. Okay. Okay, so it will go through the code.
Sir, please,
So
I'm not seeing what you are typing.
Hello?
Hello, sir.
Okay, you are hearing me. So let me read what I have here. The line, and then it brings the code. Product inventory dot key, closing, opening parenthesis, closing parenthesis, contains a mistake that needs correction. Assuming product inventory is a dictionary in Python and you want to retrieve its keys, you should use the keys. So you took your time and read all of these things. It will make you learn and understand what you are learning. Use the keys method, not key. Here's how you can correctly use the keys method. No, array constructed. We didn't even give the full dictionary. We just only passed because the dictionary had already been created somewhere. And then he created a dictionary for you because he wants you to understand how that thing is used. So a dictionary, product inventory, and he has used apple, banana, oranges. Then he's demonstrating how you use it. So he's even storing the results into a variable. So he declares a variable, keys equals product inventory dot keys. So after reading all of these things, you will come to see that, okay, this is where I made a mistake. And this is how you have to use ChatGPT. It's not like last minute, you type your assignment inside it and then you print what comes out. You are just fooling yourself. So when I do dot keys on the objects, it brings me all the keys. So it tells you dict keys. And then you see a list of all the keys: cassava, cocoyam, plantain, tomato, pepper. So this will give you an idea, okay, oh, these are the products that we have in the system. Similarly, you can do product inventory dot values. If we have keys, then we should have values. So let's do a product inventory dot. So you have to remember it wouldn't be value, it will be values. And then it tells you dict values: 100, 200, 20, 10, 90. So just by these two pieces of programming codes, you have had a good understanding of, oh, okay, what the data is. Okay, cassava is 100 because they correspond. Cassava is 100, cocoyam is 200, plantain is 20, tomato is 10, and pepper is 90. That's it. How about if you want to get the combination of key value pairs from, let's say after doing this, you want to get a full listing, the item against its value. So there's another method called items. So that is how all of these things are English. Items is not anything, it's English. Keys is not anything. And you know dictionary, you know how dictionary is structured. You should get the context. Okay, the keys are the words and then the values are the meanings. So it's around the same structure that we are creating this kind of data storage structure. So if you bring your mind and you do that kind of relational learning, it shouldn't be difficult for you. If you are lazy to do these things, it will be always difficult. So we can do products, inventory dot items, and it gives you the full listing of the products, cassava, and its value. So it is encased separately. Cocoyam and its value, plantain and its value. So this is how it brings the results to you. You can also remove items from the dictionary. You can update items in the dictionary. You can clear the content of the dictionary. Your assignment is that go and use ChatGPT to help you do that kind of assignments. So you can type it in a descriptive way. ChatGPT, how do I delete an element from a dictionary data structure? Just ask it like that. ChatGPT itself will create a dictionary data structure because it has to use that to illustrate it to you. It will not speak it in words, no, because you wouldn't understand it. These things are very technical stuff. It is the things you do, not the things you have to read without doing or hear without doing them. No. If you don't want to do them, you can never understand them. So you do that to learn all the methods about dictionary, all the methods about lists, all the methods about strings, all the methods about tuple. So now let me talk something small about tuple. Tuple is not too different from lists, except that tuple is, so let me say my tuple. Instead of using square brackets, we use this parenthesis. But the way we pass the items are the same. Item 1, comma, item 2, comma, item 3, and so on and so forth. So let's say 1, 2, 3, 4, 5. That's it. So probably you'll be asking yourself, what's then is the difference? It's the same listing with commas. The difference is one is in square bracket, one is in parenthesis. And it's still a list of items, either in parentheses or in square bracket. What's the big deal? What's the difference? The difference is that this one is also a list, but it's a list that after you create it, you can never change any of the things inside it. For lists, let me call our list here. I don't even remember. I think maybe we did it my lists. Let me call it from by that name and see. My lists. If this is how we stored it, it will appear here. Okay, so my list is here. My list is books, 1, 2, 3, pens, these kind of things. I can say my underscore lists square brackets. This square bracket means I'm accessing some value in the list or some element in the list. And in this case, I'm going to do that by index number because that's how lists behave. So when I say 0, it will bring me the first. And so this is what is at 0 index number. And I can do my lists. Sorry. My lists, square brackets, 0 again, equals, let's say, 100. We are changing the value there to a different value. And let's run it. It is executed. So now let's see the new content of my lists. 100. So this value is replaced. What I have done is what is called in programming as mutation or mutability. If I can change the content of the object, like I have done, I have changed the list of books and shoes into a value 100. I can even add something to it right now. And we had demonstrated that one the last time. So that is what lists do. Lists is that flexible. You can do all of these kind of mutations on it. But there are some instances where we wouldn't want people to be able to change the value of certain things. For example, your index numbers. If whatever system that we have it on and people are working on, we wouldn't want it to behave such that maybe by even accident, someone's hand can go and press on something and then it mistype something. No, these things are stored in this way, those kind of things that we don't want them to change. The only way you can change them is to probably replace them. So you cannot say, okay, I'm accessing value 1 like I did here, and I'm changing it from 1 to 10. You can't do that. So let's try and see that, try and work something like that and see the feedback. If I do my tuple and I access, let's say the value at index number 0. Oh, the name, so the error message is name my tuple is not defined. So how did I name it? It means I have misspelled it somehow. My tuple.
So it seems you did not run that code.
Yeah, I didn't run that cell. Good, good, good. So let me run it. And now let's run here. Yes, so it says 1. And that's true. That's the value here. And now let's try to do what I was trying to do on that, what I did on the list, this one. Let's try to do the same for tuple and let's see the feedback. My tuple 0 equals, let's do 100 as well. And now let's read a message. It says type error. That's the name of the error, type error. Tuple object does not support item assignments. Yeah, that's what it is. So when someone tries to change, let's say bank account, those kind of things, maybe credit card numbers. So the systems that are storing these kind of sensitive things are most likely to be keeping them like this so that you can manipulate them programmatically. That's the main purpose for tuples. Let's talk about strings, and then I'll come back again to dictionaries and see how it transitions us into the higher level data structures. String. So string is like a collection of characters. Usually the technical way to really understand what a string is something which is not number. And something which is not number also can be technically described as something which we naturally don't perform computation on, or which it doesn't make sense to even do so. For example, it's not even possible I can do my name divided by 2. Nobody has even thought about it in the world before. And even though I can do my phone number divided by 2 because they are numbers and it can probably produce some figure, the figure is very useless. It doesn't mean anything in the world. So things like that, which we do not perform calculations on, it can be string of characters, numbers, but they are not meant to be used for computations. All of them are really stored as strings. But naturally, when you type numbers like my phone number, the computer's first way of reading it will not be string. Because they are numbers, they are numbers. So if it is not a number, you need to tell the computer that, okay, I'm not going to store this as a number, even though they are digits. But apart from that, all other things like the ABCDs and some Chinese characters, whatever it is, anytime you type them, the program will read them. The program will not see them as numbers. The program always want to see numbers. It kind of communicates with numbers, sort of. It doesn't really know texts. So if we are storing texts, we need to tell the program, Python in this case, that please don't really think that this is a number. This is not a number. Otherwise, it will throw error. Let's try and see something like that. When I type, this is a code cell. So when I type, let's say Kofi, and I run it. So let's read name error. Name Kofi is not defined. When you define it as a variable, you would have done maybe Kofi equals and a value. That one, it knows this one as a variable name associated with a number. But just typing Kofi like this and running, Python doesn't understand it. It doesn't understand texts. It doesn't understand strings. So I need to, if I had, this is the meaning of what I'm saying. If I had typed 10 and run it, it wouldn't throw error. If I type 10 and run it, wouldn't throw error. Because it is meant to kind of dialogue with numbers. So he knows 10. He says, when you gave him 10, he says 10, 10. He brought it back to you 10. Yeah, I understand 10. But if you do Kofi and run, nah, I don't understand this. So he's trying to say, okay, probably you are trying to name a variable. Even if that is the case, I don't really know that variable. So I don't know what you're saying. So the way to make it know it is that you put it in quotation. Single or double are acceptable in Python, and run. So when you run, you spoke Kofi, and he's also speak back. Yeah, okay, I get you, Kofi. Yeah, sort of. So when I type something lengthy, let me just copy some text. So let's say, let's store this one as my string. And then we bring the quotations. And then I press enter. So let's see what is wrong. Unterminated string literal detected at line 1. Oh, okay. Okay, so the problem is here. It's part of what we'll be talking about, or if not today, maybe another time. You see, let me even explain it. How I did it is to put the string in single quotation. Meanwhile, one of the words itself has this apostrophe, which is also a single quotation. So Python's mind will read from this beginning quotation to this one, which is the UR, which is shortened, and then cut it. So it knows that this is where the string ends. And then the rest is something else that he doesn't understand. So because there's already a single quote used in one of the words, we might probably have to use double quotes to save ourselves. So double quotes at the beginning, and then we do double quotes at the end, and then we run. Okay. So my string is this whole thing. There are a lot of things that we can do. When you write a text like this, the normal things that normally we will want to do can be things like I want to change. Maybe I want to change it to all capitals. I want to change it to maybe initial word capitalized, the rest should be normal case. I want to maybe make it bold and so on and so forth. So normal text formatting you can do on this. Let's see some of them. So if I want to capitalize everything, maybe let's start with capitalize first character. There is a method which automatically works on strings to do that thing for you. It is called dot capitalize, and it is English. Capitalize, and it is dot capitalize. What's the problem? So I'll do my string dot capitalize. You just need to know how you have to spell it because it's case sensitive. Let me even double check. Capitalize. Yes. Yeah, so that's the function's name. So we are using that function on this object, so it's a method for the object. And let's see. So the dot capitalize, this is what the dot capitalize does. It capitalizes the first character. So, okay, unfortunately, you wouldn't see any change because the first character itself is capitalized. So you let me make that change. Let me make it small and run it again. And let's run our capitalize. You see that the original was a small letter, but when you do capitalize, it capitalizes only the first character. We can do uppercase. You see, that's the difference between, so capitalize is not like you're capitalizing, or capitalize is for capitalizing the first character. And then if you want everything to be capital, then that one we use upper for uppercase. So when I do my string dot upper for uppercase, then it converts all of them to uppercase. That automatically, I know you are thinking, then okay, there will be a counterpart. There will be the wife or whatever, or the girlfriend, who has to be dot lower. And let's see. My string dot lower. So what will make you okay? This one too. So let me even make the whole of the first word all caps so that you can see the change well. Okay, so this is the one with the dot lower. It lowers everything. So at least you can see that the first word in the original is capital. All of them are capital, but dot lower will make all of them lower. There are a few other methods as well. Read about them and learn about them. We don't learn in the classroom. Yeah, you learn from your own inquisitiveness, your own curiosity. You need to be curious. If you want to learn from classroom, you wouldn't know anything. Right, so that's I think what I have to say about today. Let's get back to dictionary again. The dictionary that we created, what name? We call it products inventory. So let me call it here. Sorry. So this is our products inventory. We want to look at how this data structure is very strategic because it's almost the shadow of the advanced data structure which we are going to use most of the time, data frames from the pandas package. So by that, I think I have to do this label. So let's say advanced data structures. There are a number of them, but in this particular session, we are going to talk about data frames because I just want to take advantage of the structure of dictionary. There is something about the dictionary data structure which connects so much well with the data frame structure. So that's why we are doing it like that. There are other data structures like series, which is all of them are in the same model, the pandas model. Anyway, we'll talk about them if we get them. So advanced data structures here, I'm going to just go straight to the point, talk about data frame. So in Python, the advanced data structures that we use for advanced data analytics and all of those beautiful things that you can see people doing with Python and those stuff. Most of them are carried out, if not exclusively, in pandas. Pandas will automatically be part of the whole thing, the whole process. So pandas is very, very useful, very strategic. There can never be any Python data analyst who doesn't know Python. Then you are not. You can't be. It's so fundamental. Okay. That package is already made and it is in Python already. Once you have installed your Python through Anaconda, that package is also automatically there. If you had installed it, the base, and then you installed your own IDE separately, most cases, the Python software itself, when you install it by itself, not through Anaconda, it doesn't come with most of these advanced packages because it doesn't really know what you use Python for. And the packages are there. If you need this one, you just add it on. Just add it on. So you just go and install, and it is free, it's open source, you don't buy anything. So with Anaconda, we already have these advanced data structures, in this case, pandas. So as I'm speaking, if you are curious, you might want to know, okay, pandas, maybe you can go to ChatGPT. I just want you to understand how you have to use this tool to help yourself. ChatGPT, just say, tell me about pandas. Yeah, don't talk plenty. Tell me about pandas. You can supply other contexts like, oh, I'm a beginner trying just picking interest in Python programming. So that's my background. It will keep that context for every communication, at least for that session, if your machine doesn't restart. And then you ask him subsequently, tell me about pandas. It will tell you everything. Oh, pandas, probably can even tell you a bit about the meaning of the name. If you wanted, you can ask back if it doesn't bring it. So that's how you use it to learn. I don't want to really type something in ChatGPT about telling us about pandas. You have to do that yourself. And it is beautiful. Pandas package, if you want to use it, in our case where we install Python with Anaconda, so the package is there. So you just import it. The package is there, but the package is not just around you in your current environment. It's on your computer, the files are there. Sometimes those heavy programs, if you wouldn't need them, why would you have to bring them to take your system's resources? So when you need them, you just go for them. And this is the keywords you use when you are going for those packages. You use the keyword import. And this is English, which everybody understands. Import, then the package name. So the package is pandas. Sometimes we want to, so when I run, it will run. So pandas has been imported. But sometimes we will want to type with some speed, or maybe we want our code to be more snappy. So instead of saying import pandas, yes, we are importing pandas, but after you import pandas, give pandas some nickname, which is sometimes a shorter name, shorter version of it, which can save us some time because typing pandas all the time that you need pandas dot this. Some packages name can even be more longer than pandas. So typing so many words for that name, you even make a lot of mistakes going back to correct them, wasting time. So the tradition has been to import the packages with aliases, with shorter names. And in the coding community, pandas is imported usually as PD. It doesn't mean you always have to be using PD. You can use your own thing, but because you will be collaborating with people, especially if you take interest in this and advance well in it, and you become a programmer, you will be doing jobs together with other people. And then you will have to be sharing. So you have to be consistent with what everybody is doing. So when we do this, it means that, yeah, so there's a missing keyword. This is the syntax, import pandas as. Import pandas as. So this is almost like a complete English. Import pandas as PD. So if another time there's another package which we use for graphicals, Seaborn. So if you want to import Seaborn and use Seaborn to do some visualizations, you type it the same way, import Seaborn as something. Seaborn is usually imported as SNS. So import Seaborn as SNS. And then when they get imported, it means that the packages are around for you to use in your current programming environment. So the pandas package gives us two major data structures, advanced data structures. One is data frame, yeah, and the other is series. Series is like one column of data, Excel data. Data frame is like Excel. So it gives you that structure that you see in Excel. If you have used Excel before, that makes it so fun in doing your calculations, seeing your data in some structured way. Data frame gives you that view of your data. And if you check very well, you will see that dictionary, let's go back to how we constructed it. The dictionary data structure has the shadow of an Excel-like data, a matrix data. So this is a column name and a column value. Of course, in this case, we are using 111, but we can also do a list notation like this and say, comma, 200, comma, 300 for this key. In this case, this becomes a column heading and this becomes the column values. The usual way we see Excel data, column heading, and then we see a lot of values, about 10 rows, 20 rows, and so on and so forth. So this is the same structure you're going to get. You're going to get, this is the column heading, row 1 is 100, row 2 is 200, row 3, and so on and so forth. So we already have the tabular data structure. We have the image in the dictionary data structure. So anytime you have a dictionary, you can feed the dictionary to the data frame constructor and it will turn it automatically into Excel-like data. So here, let me try and do something. Just for us to see it well, let me just make this one, all of them lists. Okay. This one, what we have simply done is that each product, like this cassava, has this list of items. In this case, it doesn't make too much sense. So let me try to change this so that it will make sense to you. So let's say we are storing your quizzes. So this is index number 1. And this is, so you can write multiple quizzes here. So maybe the first quiz, this is the list of the scores you have gotten from the things we have done. First one, you had 100. This one, you had 200. That's the meaning. So index number 2 or person 2. 3. And here, see that I'm putting these values in quotation. So I'm storing them as labels. 4. 5. So when I run this, okay, it says perhaps I forgot comma somewhere. Yes, here. So comma. I have to check that everything is okay. Here too needs to be comma. Yeah. So that's okay. Now, this is a dictionary of students represented by their index numbers 1 to 5, and the list of scores they have obtained from some courses. Let's say course 1, he got 100, course 2, from 3 courses. In the same way that we did this one, we can do products. Okay, so let me change the name to student scores. So if I do student scores, you can do the same things we did. Student scores dot student score in square brackets 1. It means I want the student with the index number 1, the scores. So it says it is this 100, blah, blah, blah. What we want to actually stress is that when we have that dictionary data structure, it already looks like a table in shadows. These are the column headings, the keys, and these are the column values. So when I pass this dictionary, let me look at the name again, student scores, into the data frame constructor, it will turn it into an Excel-like table. Let's see it. So we have imported the pandas package as PD. So I will say PD, and PD has a data frame constructor. It is called data frame. So I say PD dot data frame, but you have to type the data frame in a special way. It begins with capital D and then capital F. So it's a function. Then if I pass into this function, the student scores, student underscore scores. Let me check if that is how we did it. Student underscore scores. Yeah. So student underscore scores. So when I do this, let's give our Excel table, or the name is data frame. I'm only saying Excel because I want you to look at it from that angle. So let's call it DF. DF simply for data frame. So when I run and everything is okay, it will construct that Excel-like table and store it as DF. So when I call DF to say, okay, this is what I have for you. Okay, any questions so far? Questions? If you don't have questions, to let me know that no, you don't have questions. Are you hearing me, please? Are you there?
Yes, sir, we are here.
Yes, sir. Yeah. Tuples.
Okay. So do you have question?
No, sir.
Okay, so I want us to end the session here
We are here, sir.
so that you can also get some time and go over it.
All
So
right, thank you, sir.
we will continue the rest subsequently. Thank you very much for your time.
You're welcome, sir.
Thank you, sir.
Thank you, sir.
We love you, sir.
Then I see you.